Hey, Fourth here, and welcome to this very quick revision video based on everything that you need to know for homologous series. Okay, this is the first topic of the second unit, so let's get into it. The first thing that you need to remember is that a homologous series is a family of compounds with the same general formula and similar chemical properties. Same general formula means CnH2n or 2n plus 2 or whatever the general formula is. Similar chemical properties means that they react very similarly, so that all the alkanes will react in a very similar way. All the alkenes can do addition reactions, that kind of thing. There's also patterns in the physical properties, so melting point, boiling point. As the molecule gets bigger, the melting and boiling points get bigger as well. That's because the intermolecular forces increase in strength. If we think back to the bonding topic, when we looked at covalent molecular substances, you've got really strong covalent bonds in the molecule, and in between the molecules, you have these intermolecular forces which weakly are attracted to all the other molecules. What we're saying now is that the bigger the molecule, the bigger these intermolecular forces. So the bigger the molecule, the more energy it's going to take to separate them out, which means a higher melting and boiling point. Okay, and just a reminder from third year, hydrocarbons are compounds containing hydrogen and carbon atoms only. Okay, so compounds containing only single carbon-carbon bonds are saturated. They do not have any double bonds. They don't have, it's only single bonds. They do not decolorize bromine solution quickly. Compounds containing at least one carbon-to-carbon double bond are unsaturated. Remember, the way I describe it is that it's not saturated with hydrogen. There is space to fit more hydrogen on that molecule. That's why it's unsaturated. And they do rapidly decolorize bromine solution. That's because bromine solution is used for the test for unsaturation. It goes from brown to colorless if it comes into contact with a unsaturated compound. Okay, isomers, same molecular formula, different structural formula. They have the same number of atoms, same carbon, same hydrogen atoms, but they're a different structure. Remember, if you name the molecule and if you name it correctly, you will be able to tell if they are an isomer or not. If they've got the same chemical formula, C2H6. But they have a different structural formula, they have different names. That was a bad example because that could literally only be ethane. C4H10. It could be butane or it could be 2-methyl propane. Okay, and they usually have different physical properties. And they can belong to different homologous series. Remember that alkenes are isomers of the cycloalkanes. Okay, as I've just said. Butene, C4H8, cyclobutane, C4H8. Both got the same number of carbons and hydrogens, however, different structure, different name, does different things. Okay. Alkanes, saturated hydrocarbons, commonly used as fuel and insoluble in water. And remember, the general formula for that is CnH2n plus 2. The alkenes are unsaturated, commonly used as polymers and alcohols, insoluble in water, and this has the general formula CnH2n, so not the plus 2. Okay. That contains a carbon-to-carbon double bond functional group. Remember, a functional group is just a part of the molecule that does a job. And the number in the name indicates the position of the functional group. So but1ene, but2ene. Okay. Remember that alkenes can undergo addition reactions. So there's kind of 3 types of addition reactions that you need to know. You've got hydrogenation, which is when an alkene reacts with hydrogen to form an alkane. So in that diagram there, we've got ethene plus hydrogen. That reacts to give ethane, and that's hydrogenation. Okay. The second type is with halogens to form a dihaloalkane. You can call that halogenation. That's absolutely no problem. That would get you a mark if you called it halogenation. So ethene plus bromine would give you dibromoethane. Okay, you don't need to know how to name this molecule, by the way. You would need to be able to draw it if it asked you, but you don't need to name that molecule. And you can also react an alkene with water, which is known as a hydration reaction. Simple, if you water something, you hydrate it. That forms an alcohol. Okay, remember when you've got water like this, I'm sure the next slide's going to go over it, but I'll go over it here. The OH can go to either one of those carbons. Okay, it doesn't, so I'm glad I'm going over it. If there was another carbon here, that means that there's two products that potentially formed. You could have the OH on the first carbon or the OH on the second carbon. That would give you, if there was a third carbon, that would give you either propan-1-ol or propan-2-ol. Okay, we'll go over that once in the everyday consumer products video if you decide to watch that as well. Okay, cycloalkanes are saturated cyclic hydrocarbons. They exist in a cycle, in a circle. That's why they're called cycloalkanes. Commonly used as fuels and solvents, insoluble in water, and also have the general formula CnH2n. Okay, simple as that. And that is almost everything you need to know for homologous series. The only thing not covered here is naming compounds, which is a lot of practice based, so there's not a lot I could tell you about that. And teachers teach that differently, depending on what suits them. So it's easier to just do some practice based on what you were taught at the time by whoever your teacher is. Okay. Your task now is to go away and do the mind map for the homologous series topic. Feel free to then move on to the past papers that I have listed in the PowerPoint. And if you finish all that, feel free to go back and choose a different topic. Okay, so I shall see you all in a bit. Thank you guys and see you later.